Today's lesson is 5.5, Performing Function Operations. What that means is operations with functions. So if we have two functions, we can call them f and g, right? F of x, g of x. A new function can be defined by performing any of the four basic operations like addition, subtraction, multiplication, or division. So it can either look like f plus g of x, which is the same as saying f of x plus g of x. We could say f minus g of x, which is the same as saying f of x minus g of x. We can have fg, or f times g of x, which is really f of x times g of x. Or we could have f divided by g of x, which is really f of x divided by g of x. And we're actually just going to take the two functions that they give us and perform whatever operation they're asking. It does mention here the domains of the sum, difference, product, and quotient consist of the x values that are in the domains of both f and g. So anything that wasn't allowed in either of the functions will not be allowed in their combined function. And additionally, because quotient ends up with a function on the bottom, whatever makes that 0 is also not allowed. So in our first example here, we have let f of x equal 5 times the square root of x, and g of x equals negative 8 times the square root of x. We want to find f plus g of x. So we're really looking at f of x plus g of x. So I'm going to replace f of x with its value, 5 square root x, plus g of x. I'm going to replace that with its value. It was negative, so I'm just going to stick it in parentheses there. And if you remember from a few lessons ago, when we have the exact same radical, all we have to focus on are the numbers in front. So I'm focusing on 5 minus 8, and that's negative 3. So that means f plus g of x equals negative 3 times the square root of x. And that is my answer. The domain, right, both of these where we're not allowed to put negative numbers in, my final answer, I'm still not allowed to put negative numbers in. So my domain is going to be x is greater than or equal to 0. And the last thing we're going to do is we're going to evaluate that sum when x is 16. So we're going to evaluate this one right here when x is 16. So we're going to do f plus g, oops, let's fix that right there, f plus g of 16. And I'm evaluating this one, so that's negative 3 times the square root of 16. So I can take the square root of 16 and I get 4. So this is really negative 3 times 4, which means it's really negative 12. Okay? We'll look at one now as a subtraction, the difference. So this is a little longer. Let f of x equals 2x cubed plus 4x squared minus 8x plus 4. And g of x is 3x cubed minus 5x squared plus 6x plus 9. We're going to find f minus g of x and state the domain, and then we're going to evaluate when x is negative 1. Remember, when we're doing subtraction, we have to distribute the sign to the whole second set. So since I'm really doing f of x minus g of x, I'm taking all of this right here, 2x to the third plus 4x squared minus 8x plus 4. And I'm subtracting, and I'm going to use parentheses to make sure I do this correctly. 3x cubed minus 5x squared, there we go, looks a little more than 3, plus 6x minus 9. So this negative is really going to go to everything. So it's going to become negative 3x squared plus 5, negative 3x cubed plus 5x squared minus 6x plus 9. And now this is an addition problem, right? We distributed it to everything. And now I can just combine my like terms. So I have 2x cubed and negative 3x cubed. That's negative 1x cubed, or just negative x cubed. I have 4x squared plus 5x squared, so that's going to give me 9x squared. I have negative 8x and negative 6x, so that's going to give me negative 14x, and positive 4 and positive 9 is going to give me plus 13. So this is really f minus g of x. So that whole thing there is my answer. My domain, these are both just regular polynomials, so my domain is going to be all real numbers. And now my evaluation, when x is negative 1, we're going to put negative 1 in for every single x here. So that's negative 1 cubed plus 9 times negative 1 squared minus 14 times negative 1 plus 13. Remember, we have to do order of operations. We have to do exponents before we do multiplication. So this is negative 1 to the third power, which is negative 1 times negative. So we get positive 1. This is negative 1 squared, which is positive 1 times positive 9 is still positive 9. Negative 14 times negative 1 is positive 14. And then we have plus 13. So when I evaluate this all, combine my like terms, I get 37 as my answer. All right, next example, I have f of x is x cubed, and g of x is the square root of x. We want to find the product this time. So we're really finding f of x times g of x. So that means I'm going to have x cubed times the square root of x. And normally I would say I can't do this, but this square root of x, again, you recall a few lessons ago, can be rewritten, right? Power over root. This x is being raised to the first power, and the root we're taking, square roots, really have a little 2 there. So this is x to the 1/2. Now, if you remember from our properties of exponents, when I'm multiplying two like bases, I'm going to add the exponents. These do not currently have a common denominator, so I'm going to rewrite them so they do. So 3 is really 6/2. So now I have 6/2 plus 1/2. That gives me an answer of the product f times g of x equals x to the 6 plus 1, 7/2. All right, my domain, we're not allowed to put anything negative inside a square root. So my domain here would be x has to be bigger than 0, right? Greater than or equal to 0. And now I'm going to evaluate when x is 4. So I'm going to go up here. And now I'm going to do 4 to the 7/2. If it helps to rewrite it, we could rewrite it as the square root of 4, right? Root bottom 2 raised to the 7th power. The square root of 4 is 2, so now I have 2 to the 7th power, and 2 to the 7th power is really 128. And that's my answer. The last example we're going to do, we have f of x is 4x, and g of x is x to the 2/3. I'm going to find now the quotient. So the quotient, right, f of x over g of x is what we're really looking at. So I'm going to put 4x in the numerator and x to the 2/3 in the denominator. So if you recall, when we're dividing common bases, I need to subtract their exponents. This is really x to the first power, and 1, if I wanted to change it, would be 3 over 3. So now I can simplify. 4 over 1 is just 4. And now x to the 3/3 over x to the 2/3, if I subtract them, 3/3 minus 2/3 is 1/3. So 4 times x to the 1/3 is really my f over g of x. As for my domain, I know that I can't have anything 0 on the bottom. It was a third root, so that means negatives are allowed. So my domain is just that x can't be 0. Cannot equal 0. And now I'm going to evaluate when it's 27. So I'm doing 4 times 27 to the 1/3 power. All right, if you want to use a calculator for that, or I'm really taking the cube root of 27. The cube root of 27 is 3. So this is 4 times 3, or 12. So you're going to try the next set. All 4 of these have the same f of x and g of x. F of x is 9x plus 4. G of x is 3x plus 12. So we're not going to worry about domains for these, but you want to find the sum and then evaluate when x is 4. We're going to find the difference, evaluate when x is 3, find the product, evaluate when x is -2, and find the quotient, evaluate when x is -6. So when you're all done, pause it now. When you're done, come back and I'll scroll through the correct answers. All right, for try A, f plus g of x would be 12x plus 16, and when evaluated, it's 64. The difference would be 6x minus 8, and when evaluated is 10. The product would be 27x squared plus 120x plus 48. And when evaluated, we would get -84. Be careful with this one. It's some foiling. You have to distribute, right? It's 9x plus 4 times 3x plus 12. So you have to make sure you're distributing everything in the first set to everything in the second set, right? Like that, like that, that. And for the last problem, the quotient, we would just end up with 9x plus 4 over 3x plus 2. There's nothing to, oops, sorry, 3x plus 12. Wrote that wrong there. There's nothing to simplify here. I could take the 3 out here and rewrite it as 3 times x plus 4, but nothing's going to cancel. And when I evaluate by -6, I get 25 over 3. All right, let me know if you have any questions.